Hello, I am Min Song Kim. I'm researching the catalyst used for methane carbon dioxide reforming in Professor Jong-uk Bae's lab. I will start presentation. First is the table of contents. I'd like to introduce the research background and purpose and brief research process in order. The first is research background. As everyone in the world knows, the Earth is dying. It's because of global warming. Global warming is mainly caused by greenhouse gases caused by human production and consumption. What are greenhouse gases? Among various gases constituting the atmosphere, carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride, which cause the greenhouse effect. It's called greenhouse gases. And greenhouse effect is a phenomenon in which the sun's heat enters the earth and then cannot escape. So it makes earth hot. According to the data from Ministry of Environment in 2020, the main cause of greenhouse gases is energy use, such as public electricity and heat production, petroleum, steel chemistry, and transportation, and so on. So 86.8% of greenhouse gases are caused by energy use. But as you know, these are things that people need to live on. So it's very difficult to reduce consumption. So people are making efforts to find new alternative energy or to enable recycling. Among these efforts, reforming, which I am researching, is the production of useful syngas by simultaneously consuming methane and carbon dioxide, the main components of greenhouse gases. Syngas is a mixed gas of hydrogen and carbon monoxide used as a feedstock for chemical reaction. Syngas is a raw material for various chemical products, including ammonia, dimethyl ether, and methanol, and can be an energy source for electricity generation. So, the purpose of my research, as I just said, is to synthesize syngas by consuming methane and carbon dioxide. However, chemical reactions do not proceed as long as there are only reactants present. For this chemical reaction to proceed, there must be many effective collisions between particles. And for this, the particles must have energy above a certain amount. And this specific energy is called by the activation energy. In other words, you can think of activation energy as a hill to go from one energy state to another. You will need energy to get over the hill, and the gentler the hill, the less energy you will need, right? It's the catalyst's job to smooth out the hill. Uh, catalyst, a catalyst definition is a substance that regulate the reaction rate without being consumed in a chemical reaction. Catalysts which speed up reaction are called positive catalysts, and it's make the hill lower. And catalysts which slow down reaction are called negative catalysts. It makes the hill higher. And catalyst that is in the same phase as the reactant is called a homogeneous catalyst. Otherwise, it's called a heterogeneous catalyst. Type of catalyst include photocatalyst, which act as catalyst by receiving light, and enzymes, which are a type of biocatalyst. Catalyst materials used in reforming typically include noble metals. such as platinum, rhodium, ruthenium, and iridium, and metal catalysts such as iron, nickel, and cobalt. In the case of noble metal catalyst, the activity is good, but because they are too expensive, reforming using inexpensive metal catalysts such as iron, nickel, and cobalt is mainly studied. However, these catalysts have a big problem that's catalyst deactivation. Catalyst, uh, catalyst deactivation means that the catalyst loses its activity over time, making it slower than when the catalyst was first added. Typical causes of deactivation are sintering and coking. Sintering refers to the reduction of the active surface as catalysts agglomerate together, and coking refers to the reduction of the active surface as carbon, called coke, is deposited on the catalyst surface. As the active surface decreases, the active also decreases because the number of reactive sites decreases. So suppressing it can be said to be core on the study. Methods of suppression include suppressing sintering and coking by mixing other substance with the metal catalyst or reusing the catalyst through catalyst regeneration process. Among the metal catalysts mentioned above, I am dealing with nickel-based catalyst, and I am studying how to suppress the activation by mixing other materials with nickel. Before I tell you about the process, let me tell you about my catalyst. Uh, there is something that needs to be explained first. That is, there are three elements that makes up the catalyst, which are the active site, support, and promoter. Earlier, it was said that methane and carbon dioxide were used as reactants, but these two substances are gases, right? And do not react in the gas phase. So a site for the reaction is required, which is called an active site, and nickel serves as the active site. The support serves as a support to highly disperse the active site material and enhance the stability of the catalyst. At last, the promoter plays a helpful role, such as increasing or suppressing other specific activities. To briefly explain the catalyst I am researching, nickel is used as the active site material, and aluminum is used as the support material. And the support structure is varied without the promoter, and the catalyst activity is compared accordingly in our research, in my research. So, how can we compare the performance of this catalyst? The catalyst is placed in this reactor, and the temperature is controlled while the reaction gases, methane and CO2 are flowed. And GCTCD analyze how much the product created compared to the feed. Through this methane conversion rate, carbon dioxide conversion rate, H to CO ratio, and the activation are checked to compare catalyst performance. And we anticipate the reason for such a difference in performance between catalysts and find it through various analysis. Physics option, chemistry option, XRF, TJ, DPR, DPD, TEM, IR, and so on. This is the end of the presentation. Thank you for listening.